Whenever we're asked to add or subtract rational expressions, we know back in the day we always had to find a common denominator when adding or subtracting any kinds of fractions. So we know that's what we're going to do. Now, in this case, we have a trinomial with a leading coefficient that's greater than 1 that needs to be factored. When we look at our 6 factoring scenarios, all of which are on page 33, so side 1 of our math reference document, we can see that that falls under scenario type 5, trinomial type 2. Now, even though it is beneficial to know how to factor those, and you could check out my factoring masterclass for trinomials located under the week number 6 assignment, we're actually going to use a little bit of the answer options to our advantage. And what I mean by that is we can see that the only way you can multiply to get a 2y squared is if you have a 2y times a 1y. And so we can see in these denominators, these two binomials are all following that pattern. So what we can do is notice that, well, the 27 at the end, all these are going to multiply to get negative 27. So that's not going to really help us in any way. But as we multiply binomials, we usually follow this FOIL process of first, outer, inner, last. We can see the first and last are going to be the same in all these answer options. So let's look at the outer and inner parts instead. And when we do so, the goal is for the outer inner to give you positive 3y. So here we get negative 6, positive 9, that gives you positive 3y, so it's still in the running. This one gives you negative 6, positive 9, again, so positive 3y, that's good. But notice these ones, positive 18, negative 3, that's positive 15. So right now we could go ahead and eliminate these two answer options, and we've given ourselves at least a 50-50 chance. So think about what we've done so far as it relates to the Triple T math document. We did decide to use the answer format to our advantage. We did something, more specifically the outer inner checks. And then once we were certain that the outer inner should give you positive 3y, we eliminated those two answer options that they can't be. Now we'll analyze the remaining two options to see what makes them different from each other. So unfortunately, they're quite similar, with the only difference being the signs in front of those terms. So let's go ahead and continue factoring. We already said that this denominator is going to factor as 2y plus 9 times y minus 3. And then we'll go ahead and rewrite the 4y on top. And then we have this minus. I'm going to rewrite the y plus 1 for now. And when we want to factor this denominator, let's look at which scenario that falls under. So notice that's going to be scenario 3, where it's a binomial with x's or y's in our case, which basically means we're getting out the greatest common factor. So we're going to factor out a 3y that they have in common. And when we take it out, notice what you're doing. You do 6 divided by 3, that gives you 2. You essentially subtract the exponents. That's one of the properties of exponents. So you do 2 minus 1. So now we have y to the first plus 27 divided by 3 is 9. And the y's cancel. Now at this point, we need to come up with our common denominator. And to do so, we're going to need to account for every single component of these respective denominators. So for example, 3y needs to be accounted for. It is. The thing that they have in common are these 2y plus 9. Now, since there's no exponent outside of them, we assume that they're each to the first power. Let me give you an analogy here, or a little example that'll help to better understand what you would do if one of the exponents was different from the other. So let's say we had this. We know that the least common denominator is 9 because 3 goes into 9 perfectly. Excellent. So whenever the smaller number goes into the bigger one, the common denominator is the larger one. So imagine you have x to the fifth, x to the second. Well, as you could probably guess, the one that has the bigger exponent, just like the bigger number here, is going to be the least common denominator, since even though it doesn't seem like it, x to the second goes into x to the fifth, and you could do the division and see that that works out. So if one of these exponents were larger, let's say if one of them were to the second power or third power, you'd pick that larger exponent as the least common multiple in the denominator, which is what a least common denominator is. But since they're the same, it's going to be 2y plus 9 to the first. That accounts for those. And then we still have to account for this y minus 3 right here. So we have the least common denominator. Now, really, we knew that based on these denominators, so we could have just right away written that, but it's good to understand. Now, what is that first fraction missing that's in the least common denominator? We have the 2y plus 9, the y minus 3. It's missing this 3y. So we need to multiply top and bottom by 3y. That ends up giving you 12y squared. And then we have the minus. And notice that this denominator has a 3y. It has a 2y plus 9. It's missing a y minus 3. So it would need to be multiplied by y minus 3 top and bottom. I'm going to go ahead and distribute here. So I get y squared. I'm going to put parentheses because I want to make sure I don't forget that this negative gets distributed. In fact, I usually make it a plus and put the minus right here so I don't forget. And now we have minus 3y plus 1y, so minus 2y, and then minus 3. So let's go ahead and distribute the negative, which means flipping all the signs to the right of the parentheses. So if we combine like terms, we knew we were going to get 11y squared. That wasn't a surprise. But notice we get positive 2y and positive 3. And we could rewrite the denominator, but that's a waste of time. This matches perfectly with option A.